Hey, welcome back. This is now 10.4, and we're adding, subtracting, and dividing rational expressions. Okay, so first we'll just work with adding and subtracting, and it's just like what you did when you combine like terms. So recall, kind of maybe I don't know, an example like this, like 17x plus 3 plus just adding basically two binomials, right? 10x minus 5. Okay, so how did I do this? Well, you combine these two guys together, so 10 plus 17 is 27 x's, and then you combine these guys together, so it'd be 3 minus 5 is minus 2. Okay. So now we have sort of a similar situation, except maybe instead of variables we have radicals. Okay, so you would have maybe something like 3 root 2 plus 5 minus, or let's go with the same signs, right? Plus 11 root 2 minus 3. Okay. Okay, so you can combine these two guys together, and the way you do it is you kind of treat root 2 like a variable, right? So it's going to be 3 root 2's plus 11 root 2's equals 14 root 2's. And then, of course, you could just combine 5 and 3. That'll give you 2. And that's it. I mean, literally, that's it. So let's dive right in. We can go right to some exercises already and start looking. So here we have 9 cube root 7 minus 4 cube root 7. And it's just like 9x minus 4x. You'll get 5x, right? So 5 cube root 7. Okay, let's look at another 6 fifth root of 3 plus 2 fifth root of 3. There should be a 5. 3 minus 3 fifth root of 3. So they're all some multiple of the fifth root of 3, so you can combine them all together. 6 plus 2 is 8, minus 3 is 5. 5 fifth root of 3. Okay. One more, and then we'll worry about something else on top of it. So we have 6 root 7 minus the cube root of x, so we have some variables involved, plus 2 root 7 plus 5 cube root x. Okay. Okay, so these guys are like terms, so 6, 7, 8, there's 8 root 7's, and then these guys are like terms, so 5 cube root 3 x's minus 1 cube root x is 4 cube root x's. And then there's no more like terms, so you're stuck. Okay, so these are kind of the idea. Let's look at ones where we have to simplify first. So they may be like expressions, but you just can't see it until you simplify it. Okay. Simplify first. Okay, so let's look at 14. And we have 5 root 12 plus root 75. Okay. Okay, so I could rewrite 5 root 12 as 5 root 4 times 3. And then 75 is 25 times 3. Okay. So in the first term here, I can march out square root 4 is really equal to 2. So you'd have 5 times 2 up front, which is 10, and then root 3. In the second one, I can march out the 25. The root 25 is 5. And then you have root 3. And then you say, oh, those are like terms, so I can add those together. There's 10 root 3's plus 5 root 3's gives you 15 root 3's. Okay? So hopefully you kind of see the game that's going to be played in this section. Let's look at 3 more examples. 3 cube root of 24 plus the cube root of 81. Okay. So now I'm looking for cube roots. 24 is the same as 8 times 3, so I could pull out the cube root of 8 is 2, plus the cube root of 81. So that sounds familiar, right? 81 is 9 times 9. So 3 times 3 times 3 times 3. So you could group those together for 27, and then you just have left over 3. 27 is a perfect cube, so you can factor that out. So the first one, I can factor out the cube root of 8 is actually 2, so 3 times 2 is 6 in front, and then you have cube root of 3. And the second guy, you can factor out the cube root 27 is just 3. Okay, so you have 3, and then cube root 3. So now you see those are like terms. 6 cube root 3s plus 3 cube root 3s is 9 cube root 3s. Okay, one more, and then we'll move on to quotients. Oh, 2 more. Sorry, I lied. Cube root 24xy cubed plus y cube root 81x. Okay. The first one, cube root 24 again is 8 times 3. Then we have an x times the y cubed plus y times the cube root of 81. 81 is just 27 times 3 from above. Then times x. So the perfect cubes, cube root of 8 is 2. Cube root of y cubed is just y. So we have 2y cube root of 3x, the leftovers, plus y cube root, whoops, I forgot to march out the stuff. Cube root of 27 is 3, so I can march that out in front. Then we have the leftovers, the 3x. Okay. We could rewrite it if you wish. 2y cube root of 3x plus, instead of y times 3 times, write it as 3 with the in front. So 3 times y times the cube root of 3x. Okay. So those are definitely like terms where the kind of, they have that in common. So 2 of those first ones plus 3 of 2 plus 3, 2 of something plus 3 of something is 5 of those somethings. So we get 5y cube root of 3x. That'd be our answer. Let's look at one that has binomials in it. So I have the square root of 4x minus 12 rather. Sorry. Plus the square root of x minus 3. Okay, so that first guy I could factor out 4. I get x minus 3 here, plus the square root of x minus 3. So I could simplify the first guy. Square root of 4 is just 2 times x minus 3 plus the square root of x minus 3. So there's 2 square root x minus 3s plus 1 square root x minus 3 gives me 3 of them. 3 square root x minus 3, and that'd be it. Okay. Okay, so that's pretty much the long and short of addition and subtraction. We want to move into now division. Okay, so we have a ton of examples here. And basically what we're looking at in particular is a quotient rule. So before we had a product rule, so maybe I should remind us of that. If you have the nth root of a times the nth root of b, that's the nth root of a times b, or vice versa, right? You could go in the other direction if you wish. So this is before. Now, so this was the product rule. Now we have the quotient rule, which says that if you have let me just write it, it's easier. The nth root of a quotient is equal to the quotient of the nth roots. Okay, there I go, I got it. All right, so the nth root of a over b is equal to the nth root of a all over the nth root of b, or vice versa. Okay, you can go in either direction. Okay, so let's take a look at a bunch of variations of these kind of problems. And so you'll be breaking them apart sometimes. Sometimes putting them to using like the kind of using them in this direction, and then using them in this direction as well. And okay, so we'll see. So the first one is kind of like the forward direction, we have the cube root of 11 over 64, and they want us to simplify this thing. So you could say the quotient, the cube root of this quotient is equal to the quotient of the cube roots. So we have cube root of 11 all over the cube root of 64. Nothing you could do with the cube root of 11, right? But for the 64 in the denominator there, the cube root of 64 is just 4. So we could at least simplify that part. But then you're kind of stuck, right? Let's look at 36. The square root of 50 x cubed. So we got some variables now. 81 y to the 8th. Okay. I mean, first you always want to try to simplify if possible, but it's not going to simplify here. So I'm just going to go straight and split it up. Square root of 50x cubed over the square root of 81 y to the 8th. And the numerator, you probably have to do a little bit of factoring to get the perfect squares. So 25 times 2 times x squared times x. And the denominator, everything there is a perfect square. So you could go 9y to the 4th, and you're done there. And the numerator then start marching out the perfect squares. So you have a 5, you have an x, and then the leftover bits, just a 2x, and then all over 9y to the 4th. And I would just leave it like that. Okay. But as usual, make sure you're reading the directions to see how they want you to leave your answer. Cube root of 81 x to the 8th all over 8 y to the 15th. Okay, so I'm going to split it up into a quotient of cube roots. Then I'm going to start factoring a bit. The denominator are perfect cubes. Or that's all perfect cube stuff. Whoops, I tried to cut to the chase there. Y to the 15th. Okay, so I'm going to start factoring. 81 is 27 times 3. X to the 8th, I'm going to make that x to the 6th times x squared. Then downstairs, everything is good. The cube root of 8 is 2. The cube root of y to the 15th is y to the 5. 15 divided by 3. And then start pulling out the perfect cubes. So you got a 3 x squared, and then the leftovers, you have a 3 and an x squared as well. That's all over the 2y to the 5th. Just a couple more, and then well, a lot more, I guess. And then we'll go into, I didn't mark my video quiz question. Where is my video? There it is. Just a couple more, and then we'll go to my math lab. So 48's a little weird because you have to use the rule in the reverse direction. So I have the cube root of 54 all over the cube root of 2. Okay. I mean, you could start simplifying here, but generally you don't want to have radicals in the denominator. So if we just simplify here, you're probably not going to get a nice, well, maybe you would, I don't know. But anyways, I'm going to rewrite it as the cube root of 54 halves. And then in doing so, you can simplify the 54 halves into 27. And then the cube root of 27, we all know, is 3. Okay, so sometimes simplifying like that using the reverse direction is a good thing. Let's look at one final hard one here, and this will be the video quiz, and then we'll go to my math lab. Video quiz, video quiz, video quiz. So we have 54a to the 7th, b to the 11th, divided by the square root of 3a to the negative 4, b to the negative 2. Okay, so again, I'm going to first just rewrite it as one root and then simplify. So I have 54a to the 7th, b to the 11th, all over 3a to the negative 4, b to the negative 2. Okay. 54 divided by 3, that's 27. And then for our variables, if you have, for example, a to the 7th all over a to the negative 4 is the same as a to the 7th minus negative 4, which is a to the 7th plus 4, which is a to the 11th. Okay. So I'll have a to the 11th, and then for similar reasons, hopefully you can guess now, b to the 11th all over b to the negative 2 will be b to the 11 minus negative 2, which will be 11 plus 2, which will be 13. Okay. And then we'll simplify and plot all the perfect square stuff. Whoops, 54 divided by 3 is not 27. I apologize. It'll be 18. Okay, so anyways, looking for perfect squares now, so factoring them. 18 is 9 times 2. And then I have a to the 10th times a, and then b to the 12th times b. And then you can march out our perfect squares, this guy, and this guy. So we'll have 3a to the 5th, b to the 6th, and then the square root of 2ab for our final answer. So that'd be video quiz. That's the 4th question in video homework number 5. So once you get that 4th question, and then, you know, just go ahead and scan it and send it to my email. Okay. All right. So as promised, let's kind of mosey on over to my math lab. So as usual, I mean, you pretty much have everything you need to get through it, but if you want to, you can watch me go to my math lab and suffer through the actual assignments. Okay, this is optional. You don't have to watch, but sometimes I think it could be a good reference, right? Okay, so looks like we're in 10.4. Let's see what we're up against here. So the adding like terms are pretty easy, as long as you don't have to simplify too much. And this one, you know, this is one of the beginning ones. You don't have to really simplify. So it's just going to be 7 square roots backslash square root of 2. Okay. Okay, so that would be, you know, 5 cube root of 3. -1, -4, 5 cube square root 3. So hopefully you can handle those. And like for this one, you can only combine the square root 17s together and then the cube root x's together. This one you're going to have to simplify before you can do anything. So you get 9 square root 28 plus square root of 63. So that will be 9 square root of 4 times 7 plus the square root of 9 times 7. So that'd be, factor out the square root 4, that would give you 2 times 9 is 18, square root 7, so 3 root 7, and that would be 21 root 7. Okay, so you got to simplify first, and then you can tackle these questions. Wait a second. That one looked awfully weird. No, you're good with that one. Just simplify, simplify, simplify. I did one like that. Sure, let's try this one. So we get 7 cube root of x to the 10th y squared plus 8x cubed cube root of xy squared. You can simplify the first one via factoring. So it'd be x to the 9th times x times y squared plus 8x cubes times the cube root of xy squared. The cube root of x to the 9th will give you x cubed, so 7x cubed times the cube root of xy squared plus 8x cubes cube root xy squared. So those are like terms. Okay, so 7 plus 8 will give you 15x cubes cube root of xy squared. 15x cubed slash nert cube root xy squared. So typing them in is kind of the most annoying part. Okay, so this is just be root 5 over 6. So you're doing the quotient rule for radicals. Yeah. Let's go ahead and try this one. fourth root of 25y to the 9th all over x to the 12th. So I'll use the, the fourth root of a quotient as the quotient of the fourth roots, so 25y. I'm going to go ahead and start simplifying a little bit. So I need a perfect square, or a perfect fourth, so y to the 8th times y all over x to the fourth root of x to the 12th will be x cubed. Okay. And then there's not much I could do. I could pull out the y to the 8th over 4 will be y squared, and then you're just kind of left with the fourth root of 25y, and that would be all over x cubed. Ugh. Fraction y squared backslash nert fourth root of, oh, that's all in the exponent, don't want that, backslash nert fourth root of 25y all over x cubed. Some more of the same. So this is going now in the other direction, so you want to make the quotient of cube roots into a quotient, you want to make a quotient of cube roots into the quotient, you want to make the quotient of cube roots into the cube root of a quotient. Sorry. So let's try that. Okay. And then you simplify, so you got 48 all over 6. Oh, geez, it's just 8, cube root of 8, and then that's 2. So that one simplifies pretty well. Yay. Then, turn it into the, square root of a quotient, and then they're just getting harder and harder here. This one looks different. Okay. The way I'm going to kind of proceed is just to write it as a, so it's kind of hard to write it that way, right? So you have 147xy all over 2 root 3 like that. You could rewrite it as 1 times 147xy. Now, I would never do this, but hopefully just to kind of help me explain to you why this is the same as this. You wouldn't write this out this way, but and then you could use the quotient property to rewrite it as 1 square root like that, and then you could divide the 147 by 3. So what is that? 4, 27 nines. Then you get a nice number that you can take the square root of. So 49xy. That'd be 1/2 times 7 square root xy, which you could then rewrite as 7 square root xy over 2. Backslash square root xy over 2. So rewrite as a cube root of a quotient, simplify, cube root quotient, simplify. This one's a little different. So you want to factor that numerator and then rewrite the whole thing as the cube root of a quotient. Okay, so factoring this thing, you get x plus 4. I want to say 4 and 8, and I would be right. And then you could turn it into 1 cube root and simplify. Then you just have the cube root of x plus 8, which it is what it is, and that would be your answer. Backslash nert cube root x plus 8. perfect cubes in the numerator there. I'll go ahead and just kind of all at once pull this off. So I already kind of made it into the cube root of one fraction. That numerator, you're going to have to use SOAP on that one. So the a value would be 2a, and I usually write capital A, right? And then capital B would be b. So same sign, same, opposite, always positive. Okay, there. 2a plus little b, and then what do we have? 4a squared, 2ab, and then b squared. So you see these guys cancel out, and you just get the square root of this thing. Let's make sure it worked. Backslash squirt. A squared minus 2ab plus b squared. I must have made some silly error. Same, opposite, always positive. What the heck did I do? 4a squared. Maybe you can simplify that thing. I doubt it. Oh, I didn't put the cube root symbol in there. That's going to be an annoyance. Okay, so slash nert cube root of, wonderful, 4a squared minus 2ab plus b squared. Yeah. Okay. So maybe these are like terms, but you can't see it because you didn't. Okay, so square root of 50 is 25 times 2, 9. Square root of 18 is 9 times 2 over 7. So this would be 5 root 2 over 9 plus 3 root 2 over 7. And then I presume they want you to find a common denominator and add them together. So here you need to multiply top and bottom by 7. Here you need to multiply top and bottom by 9. Okay, so we get 35 root 2's plus 27 root 2's all over 63. Adding together, 35, 27, 2, 1, 3, 4, 5, 62. 62 root 2's over 63. Not much you could do with that. So fraction 62 backslash squirt 2 all over 63. Looks good. Simplify first. There's probably some common. It's just a more complicated. So they're making them harder and harder, right? Okay, let's try this one. 2 square root 3x to the 9th plus 32x to the 6th square root 240x to the 5th all over 4x squared times the square root of 5x to the 4th. Okay, simplifying a little bit for the first guy, x to the 8th times x plus, okay, I could simplify this part as a fraction. So 32 over 4 is the same as 8. X to the 6 over x squared is x to the 4th. And then simplify this part. So if you take the square root of the quotient, it'll be 240 divided by 5. So I'm kind of doing a little bit in my head here. So that'd be 4 and then 8. So that'd be square root of 48. X to the 5th over x to the 4th is just x. Okay. So we'll have 2x to the 4th times the square root of 3x plus 8x to the 4th square root of 48. 48 is 6 times 8, so it's probably a factor of 4 in there, right? So 4, or maybe even 16, even better. So that'd be 3. So 16 times 3 times x, excuse me, 2x to the 4th square root of 3x plus 8x to the 4th times 4 square root 3x. And then those will be like terms, right? So you'd have 2 of those, and then over here 8 times 4 would give you 32 of those. So it would be 34 x to the 4th square root 3x's when all is said and done. 34x to the 4th x square root of 3x. That's pretty much the same sort of deal. I mean, it's no big deal, it's just more complicated. Okay, so this one, they want us to find f over, so this notation is equivalent to just saying f of x over g of x. Okay, so f over g of x, you take f of x, which in this case is square root of 72x to the 8th, all over g of x, which is square root of 2x. Okay, we want to simplify this, so usually, just write it as one big root, 72x to the 8th, all over 2x. So it's going to give me square root of 36x to the 7th, and then I'm going to have to rewrite x to the 7th as x to the 6th times x. So marching out perfect squares, 6x cubed square root x. 6x cubed, and then backslash squirt of x. Okay. What is the domain? So because we have a square root of x, I need x to be greater than or equal to 0. So everything from 0 on, including 0. So you square bracket 0, comma, infinity, or inft. I don't know what I did wrong. Oh, because there's division in there as well. So if you go back here and you look at the original expression, so you have to find the domain before you simplify. I apologize. So basically, there's two things you're worried about, right? You need to make sure that this square root thingamajig is not equal to 0. And then secondly, you need to make sure that 2x is greater than or equal to 0. So sorry about that. Anyways, here you can divide both sides and you see, okay, I need x to be greater than or equal to 0. If you divide both sides by 2, which is kind of what I presumed in the first place. But then you have to make sure that the whole denominator is not equal to 0. So if you think about it, you can't put 0 in because you would have a 0 in the denominator of this expression here. So you have to exclude 0 as well, and so you'll just have an open parentheses in your answer. You can't include 0. So that's one of the weird oddities of working with the domain of these kind of expressions. I mean, we want you to find the simplified form, but you cannot decide the domain based off of that simplified form. You have to look at the original. So again, let's kind of look at this one. F over g of x. F of x is going to be the cube. So let's just go ahead and cut to the chase. The cube root of 162x to the 6 all over 2x. So the cube root, we don't have to worry about negatives. So I don't have to make sure, everything is greater than or equal to 0. The issue here is the denominator. I have to make sure that 2x is not equal to 0. In other words, x can't be 0. Okay, other than that, though, anything goes. Let me go ahead and find the simplified form now. So 81x to the 5th here, and then that would be the cube root of 27 times 3 times x cubed times x squared, which will be 3x cube root of 3x squared. Okay, so let's put that in there. They should really ask you the domain first. I mean, honestly, they're trying to nth root of 3 and then 3x squared. Okay. And then the domain, and this is a little bit weird, to write all numbers except 0, it basically have to use the union symbol. So it'd be negative infinity to the 0, open parentheses, and then unioned with 0 to infinity. So basically every number except 0. Okay, so let's try that. Negative \inf, comma 0, and parentheses. Then we need the union symbol. So I'm going to actually click on it. Don't use the letter U. You have to click on it, or it's like \cup. And then open parentheses 0 to \inf. And that should do it. Okay, the perimeter of and the area of the rectangle. So, you know, the perimeter is 2 times length plus 2 times width. Okay, and area is just length times width. So I think we should be able to handle that one. You should be able to handle that one. 37. Graph on the right. Okay, so we have a function is 5 root x plus 34.8. models the projected number of citizens age 65 to 84 in millions x years after 2010. So this is the projected elderly population in the future. X is number years after 2010, and f of x is going to be f of x is population in millions of elderly population in millions. Okay, so f of 40 minus f of 10. What the heck is this thing? So it's the difference between the number of elderly people in the year 2050 and the year 2020. That's literally what this represents. Okay, so let's go ahead and put 40 into f of x. So get 5 root 40 plus 34.8, and then minus, I'm going to need a little more room here, minus f of 10, which will be 5 root 10 plus 34.8. So that'll be 5 square root of 4 times 10 plus 34.8 minus 5 root 10, and you have to distribute the negative, right? Minus 34.8. Pulling out the square root of 4 will give you 5 times 2 in front, which will be 10 root 10. The 34.8s will cancel, minus 5 root 10, and that will just be 5 root 10 in radical form. So 5 slash squirt 10. Let's see what they say. Yay. Next, continue. Yeah, it's the increase going from 2020 to 2050. So it's the number of years after 2010. So f of 40 is the population in 2050, and f of 10 is a population in 2020. Okay. Next, use a calculator to evaluate this to the nearest tenth, and then compare it to the graph. Okay, so 5 times the, all right, so it's clear. Let's do the square root 10 first, right? So 10, square root of that, and then times 5. Okay, so 15.8. 8 million. Okay, and compare that to the graph. So up here, we want the yellow for 65 to 84, and the projected values, the differences here. So 2050 would be the 64.2, and then 2020 would be 50.6. So 13.6 is their answer. So we overestimated. So what do we have? Ours is 15.8. They want to know by how much, which is why I'm doing that part. So that's overestimated by 2.2. Yay. Alrighty then. I think we'll call it there, and I'll let you go. Thank you for watching as usual, and I will see you next time.